I was speaking for last 5 minutes without going live. Just now realized. Okay. Good afternoon. Sorry for starting late. It's 11:59, so still good morning to all of you. Let's go ahead with today's class. Hello Pinak, hello Ashia, hello Chintan. Thank you for waiting. As I had discussed earlier, this is the last theory lecture that we are taking. I will try to squeeze in one more discussion lecture or informal lecture where we will talk about the future of this course, exam, other interesting things that is happening which are related to this course, and various other ideas which can come up in the discussion. And just to remind you, that lecture would be a video lecture, so all of you please try to keep your video links on in the next lecture. So we will see each other face to face and talk. Yes, Chintan, it's good afternoon now. So let's go ahead. Today, I'm going to talk about the remaining part in the segmentation chapter, or we are not taking all the chapters, entire chapter for our discussion, only selected topics, whatever I'm discussing in the lecture. You don't have to do the entire chapter, but all I'm doing is I'm covering the basic ideas, so you have to stick to that only. Yes, Chintan, we can propose that. So, remember last class we talked about the edge based segmentation where dissimilarity is the basis. If two pixels are dissimilar, they form an edge, and that was used as the basis of segmentation. Today I'm going to discuss the similarity based segmentation. If two pixels are similar, then they form one region, then we can try to extract that region. So that is called region based segmentation. And one of the fundamental region based segmentation is thresholding, which we are going to talk about basically in this class. Intensity thresholding. Then we are going to look at various aspects of thresholding like role of noise, illumination, how to do multiple thresholding, something called as global thresholding and local thresholding. So these are the topics that I'm going to talk and discuss today in next half an hour or so. So region-based segmentation, we spoke of this in the last class also, partitioning an image into regions that are similar according to the set of predefined criteria. Those predefined criteria could be anything. Here, in this case, we are doing what is called as intensity. We are using intensity as a criteria. So the region based segmentation, this we are using intensity as the criteria. So that is called intensity thresholding. You're already familiar with thresholding in the earlier, I think in chapter 3 we talked about it, where you allow some part of the image to be at a higher level 1 and some part at a lower level 0. So that is the one of the most basic ideas in intensity thresholding. We are going to take it forward today. So if you have an image, then the segmented image can be written in this manner. So look at the histogram. If this is the image histogram, and if the image histogram has one large peak, then there is a valley here, and there's another small peak, then I can use this valley property to divide the image into two components. So this is one segment of the image. This is the other segment of the image. This value I can obtain if I know the histogram. Then this value I can visually judge and use this to segment the image. So if f of xy is my input image, and if I know this threshold value, then if f of xy is greater than threshold, then all the output image will become 1, and if f of xy is less than t, then the output image is 0. So this is a grayscale image at the input, but at the output you get a binary image, either 1 or 0. So you will get an intensity thresholding happening. Okay, so t is a constant. If this logic you apply over the entire image, then the thresholding is referred as global thresholding. While if the value of t changes over an image, say in top part t is different, middle part t is different, bottom part t is different, then it is called variable or local thresholding. So these are the terminologies we normally use. You will be using both of these terminologies very intensely in your curriculum as you go ahead. So there is something called multiple thresholding also. I'm going to come back to this a little later. Multiple thresholding can happen if there are more than one valley. So there's a valley here, there's a valley here. Now that means the entire image has three distinct regions, and I can segment them by using a thresholding at T1 and thresholding at T2. So I can segment into three levels. Here I'm assuming that I'm doing it at a global level, so entire image will be affected. I'm going to come back to this later on with an example, but do remember that the resultant image is not going to be binary. So if you are under impression that thresholding means binarization of the image, is not entirely correct. If it's a two-level thresholding, then it's binary. Remember, here the thresholding is three level. One level for this, one for this, and one for this. So later on, I'm going to show you an example that will clarify the concepts further. Success of intensity thresholding depends on the following parameter: the width and depth of the valleys separating the histogram modes. Remember, if the valleys are wide and they are deep enough, then you can separate them easily by using thresholding algorithm. Then the separation between the peaks, of course, valleys will be wide if the peaks are widely separated. If the peaks are away from each other, that automatically gives the width to the valleys, that may give width to the valleys, and the thresholding becomes an easier task. Noise content of the image, I'm going to talk about it in a while, few minutes, next two slides. If the noise is there, then it becomes challenging, and we have seen noise properties and parameters. I will recall those parameters once we talk about it. The relative size of the objects and the background, that is very important. If your background, if any of them is very overpowering, over dominating, then thresholding becomes challenging. So if your background is very large and object is very small, difficult to threshold. Reverse, if your object is large, background is very small, again difficult to threshold. The better thresholding happens somewhere in the in between arrangement. Then uniformity of the illumination source and the reflectance property of the image. So this is again a very important, especially for us, for you people who take an image every day to scan and upload as an assignment. So normally we use the available lighting at your window, tube light, phone flash, etc. Most of these lighting is non-uniform in nature. So if it's a non-uniform illumination source, then you will be at a loss, because thresholding or the PDF conversion will not work. Although most of the softwares that we use, and one software which I often suggest, that is Genius Scan, and that doesn't mean that this particular video or this particular lecture is sponsored by them, but they do a good job in their design of the software, and that is why I always recommend this. Very simple to use, they don't leave watermark, and whatever is your lighting condition, their DIP is good enough to give you the final perfect scanned black and white image, or binary image. I'm going to tell you what they do in their software towards the end. So, so these are all points which are important for intensity thresholding. So we will look into some of these at least. Some of them we have already seen, separation between the peaks. Let's talk about noise. So role of noise in thresholding. I have this image which does not have any noise. In this, I have mixed a noise of standard deviation 10, and in this, I have added a noise of standard deviation 50. Now the question is, if I want to threshold, which one will be easy to threshold, which one will be challenging to threshold? So obviously this is easy and this is challenging, as we have already talked, but how much challenging would it be to threshold in this? Now, if you look at this carefully, you will find it does not look too challenging, because you can still see a gray area and you can see a very light area in the middle. So you will feel it could be little challenging, but not much. But that is not the case. You will surprised when you see the histograms. So no noise means this is all one gray and this is light gray. So you have two peaks, sharp peaks. Okay, this is at around 65 and this is around 180. This one. Now what happens if I add the noise? So remember, when you add the Gaussian noise, what it leads to is broadening of the histogram. So what it will happen is, the histogram keeping these points at the center, histogram will broaden up. You can now see that thresholding this is absolutely a cakewalk, but thresholding this is also not challenging. You know that your threshold is still at 127. Use that as the threshold value. Put all this to 0, put all this to 1, and you are done. What happens if you go to noise of 50? So look at the histogram and you will surprise that two peaks, their bases gets broadened by so much that the two peaks merge into each other. As they merge into each other, you would realize that it's difficult to figure out the threshold and apply thresholding. So it becomes more challenging that how, or it becomes more challenging here to apply the threshold and get the two regions segmented easily. So noise plays a very important role. Perhaps in this case, if you have an image like this, you can go ahead with thresholding easily. But if you have an image like this one, then perhaps you need to apply a suitable averaging mask, reduce the noise. Reducing the noise will bring some of the values in the histogram, and then you guess your thresholding or your threshold value, and then go ahead and threshold. So that's how you typically do when there is an intense amount of noise present. So before you do a threshold, you take a small sample of the image, find the histogram. From the histogram, you try to judge whether you can apply a threshold or not to the entire image. You can take multiple samples, 3 4 from 3 4 different corners, check their histograms, and figure out if the thresholding is a suitable technique here or not. Remember, these are all global. Role of illumination and reflectance, again, that is a straight important thing. This is an image with little bit of noise, as we have seen. This is the histogram. But suppose if the illumination or reflectance, any of the two, is not uniform. So here, this image gets an illumination which starts from some gray and toward darker gray and goes towards lighter gray. So if this image receives this kind of illumination, or maybe this kind of reflectance, anything, there is the histogram for this, then the resulting image, which is a multiplication of the two, would be this way. That means the image is there, but it is dark at one side and bright at this side. This is how you take an image. If you click an image in the window, stand at your home window, especially either at the morning time or at the evening time, when there is a strong side light, and then you try to take an image, you will find that your face, one part is strongly illuminated while the other part goes in a strong darkness. Remember, what was separable here at threshold of 127 is now lost in this. You will find that you still have some valleys, but they are not widely separated, not deep enough, and therefore very difficult to figure out or to find out the cutoff or your threshold. So illumination plays a very important role. So typically you need to correct the illumination physically. If you are taking an image, and unless you intend to take an image which has a graded illumination, you need to correct it physically. So there are many ways to correct it. For example, photographers use reflectors. If you have seen any professional shoots or professional photography happening, then you find that there are people who stand with large white clothes, curtains, or maybe large piece of thermocol, white thermocol. Thermocol is banned now, but some material now similar to that. Now, all these are nothing but to correct the illumination, to correct that gradient in the illumination. At home, you can try using a white paper. The other tool which is typically used is a diffuser. So if you have a frosted glass in your window, that's an excellent diffuser which can be used to diffuse the light and directionality. The if you if you use, say, a white, thin white curtain, it is again a diffuser. So if you go to a, say, a small studio to get a photograph, passport size photograph done, then you find that they use umbrellas and other stuff to diffuse the light. A light cloud cover diffuses sunlight. So an ideal day for a portrait picture in the daytime would be the when there is a slight mild cloud cover. Dark, I mean, strong cloud cover, not dark, but strong cloud cover is not so suitable. Think why. So these are various ways by which you correct the illumination physically. Even the butter paper helps a lot. So if you are taking an image with your mobile, stick a small amount of butter paper on the camera flash and it gives out a diffused light then, and you will avoid these kind of directionality. Then suppose you can't avoid it or you have already obtained an image which has a strong gradient in the illumination, then you apply then algorithms which are inverse of the illumination. So you apply corrections, you apply divisions, etc., which is the inverse of the illumination. So so that the gradient is removed at least to some extent before you do the thresholding. Remember, our aim is to do thresholding, and as we had seen, the gradient in the illumination will not help you to do the thresholding, so you have to remove it. Or thirdly, use local thresholding. At least global thresholding will not work here. I'm going to give you an example of this towards the end of this lecture. So use local thresholding to do it. Now, what is global thresholding? Global thresholding is very straightforward. It is applied to the entire image. Now, if you know the initial global threshold value T, do the thresholding at that point. But in some cases, you may not know. Remember, in that case, we can use an algorithm to calculate the threshold. Listen to this algorithm carefully. You can implement it using Python very easily. It's very simple algorithm. If you know the threshold, then easy. Anything less than t is 0, anything greater than t is 1. If you don't know t and if you don't know the histogram also, then you can write the algorithm and calculate the t. So very straightforward. You first take some global threshold t, some arbitrary value chosen towards the middle. So if it's 0 to 255, maybe 128. You divide the image into two groups. Then for each groups G1 and G2, you find out their mean values. And then from the mean values, you find out the average of the two means. Once the average of the two means you use, that will be your new threshold value. And then you divide using that new threshold value, you segment the group image into two groups once again. Again calculate two means, again calculate new threshold, and go ahead, keep doing it in the cyclic manner. Each time when you calculate the new threshold, you find the difference with the previous threshold. That difference is delta t, and then you can set a limit to stop. So delta t less than some particular value, then you stop. If delta t is greater than some particular value, then keep doing this again and again. So although this looks taxing, but it's not. It's very quick value to reach at a suitable global threshold automatically if that information is not available to us a priori. Here is an example of global thresholding and this algorithm being used. So this is the original thumbnail image. You can see that after thresholding, it becomes a much better image to deal with, to compare with, to count or calculate. Going ahead, you can apply multiple global thresholding, and I'm just going to show you an example. Remember earlier I'd show you the formula ABC. You have three parts of an image. You can threshold it at three different levels. So here we have a mountain terrain. This is one bright, this is gray, this is dark, but this is a grayscale image. There are various shades of gray here and here. And if you look at its histogram, then it has 1, 2, Valleys, so I can take a threshold here, set all these to a lower value, so this is a dark black. I can take a threshold here, set all these to say white 1, so all these are regions are here, and set this to 127, which is middle gray, so that all value is over here. So I can segment this image into 3 segments, 3 regions. This actually more clearly specifies the region based segmentation. I'm not dividing this part and this part using the edge based segmentation, which was the topic of discussion in the last class. In this class, it is the region based segmentation. So this part are all similar more or less, so they go in one region. These are all similar, they will go in other region, and this is here. This image particularly has used something what is called Otsu's algorithm. Otsu's algorithm, we are not keeping, when you pronounce Otsu, sometimes T is silent, or some people call it Otsu's algorithm. Uh, we are not keeping that algorithm for the exam, but I would strongly recommend that please read the algorithm, because that helps you to divide the image into as many thresholds as possible, and as a result you can have each regions independently appearing in different shades of gray. So that is multiple global thresholding. Now the last topic of the day, and that is the local or variable thresholding. So what is local or variable thresholding? So remember, we basic approach is that instead of calculating the threshold globally, we calculate the threshold at every point depending upon the properties in the neighborhood of that point. So most of the time the properties which are used are mean or the standard deviation in the neighborhood of xy. Suppose you take any xy, then you can select a small region surrounding it, maybe 3 by 3, 5 by 5, depending upon how you define. Then you find out the mean in that region. Then if the mean in that region is greater than something, then assign that pixel as 1. Mean is in that region is less than some threshold, then assign that pixel as 0. And that is how you make a local thresholding depending on a small region in around that point. You can take a combination of the two also. That is, mean is less than this and standard deviation and greater than this. Then you set it to 1 or set it to 0, depending on how you do it. So you can do it this way. Now remember, this will change from point to point. Every region, you go to the next region, pixels are different, values will different, threshold point will be different, result will be different. So your thresholding happens from one region to other region. That is why we call it as variable thresholding, because the threshold keeps varying from one local point to the next local point. Also called local because we are taking small area into considerations. So as I said, mean and standard deviation are very common. So you can take the mean in a given region and standard deviation, and a combination of the two by using two constants a or b, and define your threshold. So if A is 0, you are only using mean. If B is 0, you are using only SD. If both are there, then you are using both. You can adjust the coefficient to give the weightage to them, and you can calculate your threshold locally for the point xy. And of course, if the function has the value greater than txy, set it to 1, less than or equal to txy, set it to 0, thresholding is done. So this is how we do our local or variable thresholding. Sometimes this can be modified even further as moving averages. So you take the average in a small interval in small region, and then when you move to the next region, then you overlap with the previous one. Like suppose you take select any pixel, surrounding that you took a 3 by 3 region, then you move the central pixel by 1 and select the new 3 by 3 region. Then the previous 3 by 3 region and the new 3 by 3 region will have one column, one column common. So the region which is used to calculate average in the previous calculation, part of that region would be incorporated in the next calculation also. So this is called moving averages. This is the mean for the moving averages. You can read through the reference and get this. It is something like for corona cases, we normally don't look at the everyday data because everyday data has lot of fluctuation. What we look at is moving averages of 7-day data. So we take last 7-day average and take that data as our reference. So if your day increase by 1, still from the previous calculation and this calculation, 6-day data remains common. So that's the moving averages. So one of the very interesting results of moving averages is here. I have this image, and you all must have obtained this image in your work. This is your notes written with hand, and since the teacher has asked to upload it in Canvas or Google Drive, you took an image. It was late night, everybody was sleeping. You have to use the camera flash to click this image. The moment you click this image, the camera flash is a point source of light, and it is going to give you a radial intensity profile. Center, it is going to be brighter. Towards the edge, it is going to be darker. If you don't believe me, you can do it tonight, or any room which is dark enough, you can use this and check it out. Now, this is not a very clean image. In fact, if you upload it this way for a DIP assignment, you must get 0. Because after all, you are a DIP student. You cannot submit this kind of image of your assignment. Make it better. Now, one of the ways to make it better, people can try. There are many ways, but of course, one of the ways, as I said, you can correct the illumination to begin with. You can make the light softer, flatten out. You can apply an inverse of intensity. You can do a lot of other corrections. But of course, if those are not available, then somebody tried thresholding, and this is the result of the global thresholding. The global thresholding says that I will apply one threshold for the entire image, and anything darker than that will become black, anything brighter than that will become white. It's very interesting. You people can do it and see. In fact, if this is a perfect circle, that means the source of light that you are using, your mobile flash or whatever, has a very radial divergence of the light intensity. So that nature can be checked by the shape of this mask or circle. So if it's a perfectly radial, then as you go towards this side, the intensity drops and eventually it will become dark. So the corners will become dark, but in the center, these points will become white. So these are all white. And of course, the handwriting is black. But you can see a lot of data is lost in this case. How to make it better? We can make it better by using what is called as local or variable thresholding. So in the local thresholding, we don't look at the entire scan, but we look at a small region. So we'll first look in this region only. Now in this region, I know that my mean value is very less, it's very dark. And in that less mean value, I will try to distinguish between the dark gray of handwriting and little less dark gray of background, and I will threshold it. So background becomes white, handwriting remains black as here. But it's a moving average. I go to the next, I go to the next, I go to the next. Every time you can see my intensity is increasing. In fact, as I come into the center, the intensity goes on increasing. But Since I'm looking only at a small picture there, I can threshold it clearly at all points. And my final result is going to be much better than what I will get it with global thresholding. So typically, most of the professional scan softwares, and particularly uh, one I always use, Genius Scan, they use this algorithm to give you in very badly clicked, hurriedly clicked images also in a very perfect shape at the output. So yeah, so that's local or variable thresholding. So remember, thresholding is a very important concept. In fact, if you are dealing with astronomy, astrophysics, stellar images, then all the time you are actually talking with talking about thresholding, taking data out. So do practice these topics properly. So with this, we can stop this today's class here. Thank you. We will meet in the Google Meet. I will be there in a while to take the discussions forward.